The greatest common factor is always going to be the first type of factoring you look for whenever you try to factor a problem. In class, we're going to call this GCF, greatest common factor. Alright, so in this first example, 2x plus 6. The common factor is anything that both, or any factor that both of these terms, 2x and 6, have or share. So, 2 and 6 are both divisible by 2, meaning we can factor out a 2. So, essentially what you think to do is take out this 2 like this, and then you're left with x plus 3. But you can't just have x plus 3. You have to actually pull out the number you divided by. So this is how you factor using the GCF method. Let's look at another example. If I had 10x minus 5, well, this first problem has a 10 and a 5, and there is a number value that they both share. Well, what value goes into 10 and 5? Well, that's 5. So we're going to pull out a 5, and then the next question you ask yourself is, okay, well, can I pull out any variables? No, you can't, because that 5 doesn't have a variable over here. So this x just stays where it is. So we can only take out a 5. So if I take out a 5, meaning I'm factoring out, another name for dividing out, so 10 divided by 5 is 2. That x stayed there. And then if I take 5 from 5, that's 1. So this is the biggest mistake people always forget whenever you get 1. If you take the whole factor out, that whole 5 came out, you have to leave 1 there. Okay, so if you started with a binomial, you need to end with a binomial in parentheses. The best part about factoring is that you can always check yourself. So if you take this 5 and you were to distribute it back through, you should get the original problem we started with. 5 times 2 is 10. So you have 10x minus 5 times 1 is 5. So we're good. Alright, let's try a problem that's a little bit more involved. Okay, 3x squared plus 27x. Okay, now, we always look at the numbers first and then we move on to the variable. So is there a number that 3 and 27 share? There is. It's a 3. So we're going to factor out a 3. Okay, now we look to our variables. So I have x squared here and x here. So essentially I have an x times x over here and I just have 1x over there. So I can actually factor out 1x. Now, I can't factor out 2 because this factor over here, or this whole term, 27x, it doesn't have 2 x's to give me. It only has 1. So we're going to pull that out completely. So now we're going to see what's left over. 3 divided by 3 is 1. X squared divided by x is just x. 27, if you take 3 out of 27, you get 9. And then since you took the x out, that's it. We're done. So you're going to go back and double check. 3x times x is 3x squared. 3x times 9 is plus 27x. Alright, this next one's a little bit tougher, but see, if you think you got it down, see if you can figure this one out. And it's going to be a trinomial here. Alright, so with my numbers I have 10, 20, and 70. So what number goes into all of those? And again, it's the greatest common factor, so it has to be the greatest number that can go into 10, 20, and 70. Well, that is 10. And then you move on to the variables. Well, I have 3 x's here, I have 2 here, I have 1 there. So we can only take out 1 because the lowest x we have is 1. again, this last term, 70x, it doesn't have 2 x's to give us. It doesn't have 3. It just has 1. So that's the most amount of x's we can take out. All right, so this first term then is going to end up being x squared. Then 10 out of 20 is 2. X out of x squared is x. And then you have minus 10 out of 70 is 7. And then x out of x is 1, so we just have 7. If you were to distribute this, 10x times x squared is 10x to the third. 10x times 2x is plus 20x squared. And then 10x times negative 7 is minus 70x. We have 2 more problems left to go over. And before I do that, I just want to let you know, I can't show you a whole bunch of GCF problems. There are so many out there. There are common factors between a whole bunch of numbers. There are common factors between any variable that's given. But these next 2 examples are a little bit tougher because they involve more than one variable. So let's take a look at these and then we'll do a ton more practice in class. Alright, so if you were given 44xy minus 4x squared y to the third. Alright, so just like we did coefficients first and then variables, we're going to do coefficients first, then the x variable first, then look at the y variable. So, is there a number that can be divided out of 44 and 4? Alright, that number is 4. So then, you have 1x here, 2 here, so the most you can take out is just 1. Then you have 1y here, you have 3 here, but you can still only take out 1. So then, 44 divided by 4 gives me 11. I took out the x, I took out the y, so we just have 11 right there. So since we started with the binomial, there is a second part that completes the binomial. So 4 to 4 is 1, so we actually don't need to write 1, but you can if you'd like. And then I had 2 x's, and I took out 1, so I have 1 left. Then I had 3 y's, I took out 1, so now I have 2 left. And this is our final answer in complete factored form. Alright, so last challenge problem of the day. You go ahead and try this one after I write it and see if you get what I get. Okay, so again, we're going to start with the coefficients first. Alright, so I have 3, 9, and 2. So is there a number that goes into all of those? Well, there's a number that goes into 3 and 9. It's 3. But since this is a trinomial, you have to be able to factor out something that every single term shares. So this 2 right here, since it's not divisible by 3, you can't pull a 3 out of a 2, it messes us totally up. So I can't take any coefficient out. The 3, the 9, and the 2 have to stay put. Alright, so moving on to our x's. I have 2 here, 2 here, 1 there. I can still only take out 1. Then I have 2 y's, 1 y, and 2 y's. Because of this one right here, I can only take out 1 y. So what's left over? Well, I didn't take out the 3, so that stayed. I took out an x from 2, so I have 1 x left, and the same thing, I have 1 y left. Alright, moving on to our middle term. Again, we left 9 there. I took out 1 x from 2, so I have 1 x left. I took out the y, there was only 1, so I don't write it at all. Plus, again, the 2 stayed. I took out that x, so we don't write it. Out of 2 y's in the original, I took out 1, so I have 1 y here. If you got this one right on your own, that is awesome. We're going to do a lot more practice in class.